Right, lesson 2, relating the characteristics of an exponential function to its equations. So we're going to recall the characteristics of exponential functions by examining the equation this time. So lesson 1 was about the graph. Lesson 2 is about the equation. So we can determine that the function f of x equals 1, 2 to the power of x can be used to characterize the table below. So we put each of these x values in and found our corresponding y values. So just for practice, I want you to graph the function. So you're going to put this in your graphing calculator just to practice getting used to all of these steps. All right, and we're going to examine the graph to determine the y-intercept. So to do this on your calculator, once you have it graphed, so when you're in your graph function, you're going to hit second, trace. This is going to pop up your calc menu, and you're going to go to 1 where it says value. Then it's going to ask you to enter in a value for x. Because we are dealing with a y-intercept, our x is always equal to 0. So you're going to hit 0 and then you're going to hit enter, and that's going to tell you what your y-intercept is. So you're going to figure out your y-intercept is 0, 1, and hopefully by looking at your graph you can see that it's increasing. All right, so we're going to choose a new function. Let's say g of x 4, 3 to the power of x. Again, take a second to graph that into your graphing calculator, and hopefully you find out that your y-intercept is 0, 4, and we are once again increasing. Right. Consider the exponential function h of x equals 2 times 1/3 to the power of x. Again, throw this into your calculator and graph it. Determine that our y-intercept is 0, 2, and this function is decreasing. All right, so I want to know how we can predict the y-intercept from just looking at the function. Well, if we look at the function here, let me get my new color. We had an a value of 1, y-intercept of 1. A value of 4, y-intercept of 4. Didn't matter if we switched to decreasing, a value of 2, y-intercept of 2. So, sorry, hit a button. Our y-intercept is always just the a value. Now there are some cases where our function is just written as y equals 2 to the power of x, and there's nothing actually written in the a value. In these cases, we have to remember that there's an invisible 1 here. Not 0, because if it was 0, our entire function would disappear. So it's an invisible 1. So in this case, our y-intercept would be 0, 1. And that wants us to look to see if we can predict whether a graph is increasing or decreasing just based on the function. Well, we had 2 cases when we were increasing. So I was increasing with this function here, and I was increasing with this function here. But we were decreasing with this function. So as you can see, we need to look at our b value in order to determine if we were increasing or decreasing. So if b is greater than 1, we are increasing. But if b is between 1 and 0, so meaning we have a proper fraction, or a decimal that starts with 0, then we are decreasing. So look at the A value to find y-intercept and the B value to determine increasing or decreasing. All right, let's go try out these new skills. For the equation y equals 2 times 5 to the power of x, predict the number of x-intercepts. Well, we know this never changes. It is always 0. Y-intercept, well, we got to look and see what is our A value. So our y-intercept is 0, 2. And behavior, all exponential functions start in quadrant 2 and end in quadrant 1. Domain for all exponential functions is x belongs to the reals. All ranges. This part here, the y belongs to the reals, you don't necessarily have to write that every time. It's kind of like writing the 2 here. We just know it's positive. If we don't write this, we just assume it's all the reals. All right, and whether or not we're increasing or decreasing, well, we got to look at our 5 here. And we say, okay, 5 is greater than 1, therefore we know that this function is increasing. All right, so at this point, you're going to pause the video, you're going to try this your turn, and you're going to come back and see how you did. All right, number of x-intercepts never changes, that's 0. Y-intercept, we got to look here. So we're 0, 9. And behavior, always quadrant 2 to 1. Domain, always real numbers. Range, always greater than 0. And to tell if we're increasing or decreasing, let's look at that B value. Well, 2/3 is between 0 and 1. Therefore, we know this function is decreasing. All right, number of x-intercepts, always 0. Y-intercept, we gotta look here. So we know it is 0 and 10. Always quadrant 2 to quadrant 1. Remember, all exponential functions. All right, last one requires a little bit of thinking. We got to go look at that value of b. We see that 1.5 is greater than 1, so we are an increasing function. All right, check how you did. And let's try this next example. So now that we know the properties of our graphs and the properties of our functions, we're going to see if we can combine the two. All right. So the way that I always start these, the easiest, is I find the y-intercept of all the graphs. So we're going to match our graphs to our functions. So I'm going to look here. Okay, so my y-intercept is 2. So this way I know in my function, my a value has to be 2. I look here. My int is 3. Therefore, my a value has to be 3. Y-intercept is 4. Therefore, a has to equal 4. And again, our y-intercept is 4. So a equals 4. Just by doing that, I can already figure out 2 of my equations. Because if a has to equal 2, well, if I look at my functions, 3, 4, 4, here's an a value of 2. So I know that this graph belongs to the function k of x. If I look at my a value of 3, Well, there's only one function that has an a value of 3, so I know this guy has to be the function f of x. The trouble comes with if I have an a value of 4 and an a value of 4, well, that could be either this one or this one. So this is when we have to switch and now look at our b value. So this is an increasing function. So we know that our b value has to be greater than 1. This is a decreasing function. So we know our b value has to be between 0 and 1. So let's take a look. B value greater than 1. Well, that's this guy right here. Oops, sorry, wrong one. It is bigger than 0, but that is already our claimed. Sorry, looking at our 4s, we want a big b value greater than 1, so that's this guy here. So we know this is g of x. And now I want a b value less than 1, but bigger than 0. And that's this guy right here. So this is h of x. Alright. So there we go. We matched our graphs to our functions. So now you're going to try this one on your own. Come back and see how you did. Alright. Let's see. Y into 0 and 1. We know a equals 1. This one, we have a y-intercept of 0, 1/3. So we know a equals 1/3. Y-intercept of 0, 1. And a y-intercept of 0, 3. So we already have two different a's. So I know that this guy has to belong to this guy. So we're done with that one. I have an a value of 3, an a value of 3. So I know that this guy is h of x. Alright, so now we got to look at our increasing, decreasing. This guy is decreasing. So b is between 0 and 1. This guy is increasing. So b is greater than 1. So b is greater than 1. There's a b greater than 1. Remember, when nothing's written out front, that's how we know that I have a value of 1. So this guy is g of x, which means k of x goes up here. Alright, so summary, key ideas. In a table of values for an exponential function, there's a constant ratio between consecutive y values. Means we're multiplying by the same thing by every time. But the way that I told you to remember is we either increase or decrease rapidly. So in an exponential function of the form y equals ab to the power of x, a is always a non-zero, b is our base, and a is the y-intercept. So that's the key one there. A is that y-intercept. We know we're increasing if b, oh, I have a typo here. Sorry, we're increasing if b is greater than 0. And we are decreasing if b is between 0 and 1. So changing the parameters a and b in an exponential function does not change the number of x-intercepts, the end behavior, the domain, or the range. Those four things are always the same. Only the y-intercept and whether we're increasing or decreasing changes. There you have it. That's the end of lesson 2. This is your homework that is due Monday.